the second section of the, or the second part of this new section that we're dealing with in chapter 12 deals with mole fraction. This is the second of the four ways of determining concentration, comparison of mass of solute with mass of solution or solvent or whatever it is looking for. And this to me is the easiest one of the four to figure out because all you have to do is figure out the number of moles first. So it's been a while since we used moles, so we're going to get some practice on that. But this is called the mole fraction because you're going to say if you have two solutions, two compounds making one solution rather than compound A, compound B, then the mole fraction can be determined by finding the number of moles of each compound, then comparing one of the substance's number of moles to the sum of all the components' moles. So, like, let's suppose, so what I'm saying here, X means mole fraction, and we want to compare A with everything else, and say we have A and B as the two compounds making the solution here. So, we're going to take the number of moles of A and divide it by the sum of the moles of A plus the moles of B. And if you recall, you simply find moles by taking the mass of the substance that you have and converting it to moles by multiplying by 1 mole over whatever you get in the periodic table to give your answer. Okay, so this is the formula that we're looking at here. If we go back to our description here, this is the formula right here. X sub A, that should be sum, and I'll have it fixed by the time I get the scripts out to you. But it's X sub A equals moles of A divided by the sum of moles of A and moles of B. And you can do X sub B same way, is equal to moles of B divided by the sum of the moles of A and moles of B. In this case, X sub A plus X, and actually X sub B. Good typing on my part. And like I said, by the time you get the script, I'll have it fixed. They should add it to 1. And it's possible to have more than 2 substances in your mixture. And that's no problem. If you got like, say, 4 or 5 or 6 or whatever, you find the moles of each component. And it's say, in this case, we're trying to find the moles of A. And that means then that the mole fraction of A, we take the moles of A divided by the sum of all the moles of everything else. Okay? So, example here, what is the mole fraction of each component when 47.5 grams of sodium chloride is mixed with 90.0 grams of H2O? So we go to the periodic chart. Sodium is 23.0. Sodium chloride, chloride is 35.5, and that gives you a grams per mole of 58.5. But because we have grams in the numerator here, grams will have to go in the denominator here, and we have 1 mole on top, and it's going to give you 0.812 moles of that sodium chloride. Do the same thing with water. You get 90 grams times 1 mole over, and then you do the molecular mass of water, which is 18.0 grams. And you get 5.00 moles of Wawa. So now the mole fraction of the sodium chloride is going to equal to the number of moles of sodium chloride, which we said is 0.812, divided by the sum of the sodium chloride and the water together, and then divide those two out. This is not a percent, so we don't multiply by 100. We just leave it as a decimal, and there's no label because the labels here cancel out. Moles at the top, moles at the bottom. Goodbye. And you're left with 0.0828 for the sodium chloride. Then you do the same thing with Wawa. So you take 9 moles, divide by 0.0812 and 9, add it together, you get 0.917. Or all you had to do was take 1 and subtract 0.0828, and you get the same answer. So like I said, this is pretty simple. It's just a matter of an extra step involving the periodic table, which is things you did a bajillion times in Chem 1. I don't think you have much of an issue. But if you don't remember, just remember, talk to me, we'll get you through it, and you'll find that this is actually pretty easy. And the applications for this is nuts. I mean, there's we're gonna do a lab on this that I really have never done before, but I really like. And it's gonna teach you a lot about weather. So we'll deal with that in a week or two. For practice problems, I want you to do problems 49 and 50 on page 547. Okay? All right, good luck.